everyone. Welcome back to KXAN Live. We're back today with our space-based segment with our reporter, Eric Henriksen. Eric, how are you doing this morning?
I'm doing fantastic. We're going to talk about a little space. There's a lot of space news this week, but we're going to kind of hyper-focus on one thing. There was a comet that flew over, but we already talked about that a little bit. There was I don't know if you saw SpaceX caught a rocket.
Yeah.
It had like a robot arm. We're not going to talk about that either. We're talking about something else.
And we also saw the northern lights in Texas too.
Yeah, I didn't get to see them. I went outside hoping, but I'm in the kind of, not in the city, but like on the edge of the city. And I was looking like, maybe I can see it. Nothing, sadly. One day I'll see them.
But we have some exciting news from our UT Austin campus. What can you tell us about their next project?
So they are involved with the Europa Clipper mission. So Europa Clipper launched yesterday around noonish. Out of Florida. And Europa Clipper is our next big mission in space. We're going to visit an alien world. It's the largest spacecraft we have ever deployed to another planet. There it is. There's the launch yesterday. Pretty cool. It's aboard a SpaceX Falcon 9 rocket. Falcon 9, yeah. Really big rocket there. It launched up, carried Europa Clipper. It's going to be sailing. I'm going to say sailing, but it is using rockets. It's going to be heading towards Jupiter and the planet, or in its moon, Europa, over the next few years. It's a really cool mission. It's our first real up-close look at Europa. And aboard is a piece of technology called Reason. It's a radar system that will be used to analyze what's beneath the ice on Europa. So Europa has this icy shell that surrounds it, a really cold, really thick icy shell, but beneath that icy shell is an ocean. And this radar system, Reason, will be scanning that ocean to give us new data on what's underneath there. And the hope is maybe this is where that CG at the bottom of your screen says search for alien life. This is the search part. We're hoping that there might actually be life forms beneath that ocean. And so this Europa Clipper, which will get to Jupiter in late spring, early summer 2030, is going to give us that information and let us know, hey, maybe there is life underneath these oceans, life in our solar system. Pretty cool. And Reason was developed at the University of Texas in Austin. I've met some of the team members involved with it. It was using technology they originally developed to study Antarctica. Mm-hmm. And NASA came to them in the late 80s and said, hey, we'd like some of you to be involved. Don Blankenship is the research scientist heading up that charge out of UT, part of this mission. They had a watch party yesterday. They messaged me and said there was a watch party happening where they finally got to see all their work head off to Jupiter. And yeah, it's pretty cool. Really cool mission.
That's interesting. So they are not finding actual little green aliens. Me? Do you think they will?
Probably not. I'm thinking it's going to be like bacteria or like little biological organisms, something small. Detecting what it is going to be challenging. The ice is very thick on Europa, so it's not like we're going to drill. But what we'll get is like energy. They're going to look for energy. They're looking for ocean currents, movement, that kind of thing. And so they have 9 instruments on board Europa Clipper, and they're all doing various things, measuring the atmosphere, measuring water vapor plumes that are coming out of the ice, things like that. And all those are very important because it's the signs of nutrients mixing within that ocean. And as nutrients mix in that ocean, it allows for life to form. That's kind of how life formed on our planet millions of years ago, billions of years ago. And hopefully the same thing's happening on Europa. And if it does, that's really cool. Europa's in a unique situation because Jupiter is right there, and Jupiter has a radiation field, magnetic sphere, 20,000 times more powerful than Earth's. And so it's highly radioactive. And so one of the things about Europa Clipper is it's going to do these flybys of Europa. But to do that, it can't stick around. It kind of has to like arc out and then back so that it doesn't get exposed too much to Jupiter's radiation field. So it has these quick little flybys that's going to be doing over several years to get all this information about that moon. So this highly radioactive, and which also means the ice shell helps theoretically protect any life forms beneath that ice shell from that radiation, which is pretty cool. These are animations, obviously, because A, we don't have cameras out that far, and B, the spacecraft isn't out that far yet.
So how did UT get involved with this project? So
NASA came to their team and was like, hey, we know you're developing stuff to study the ice beneath Antarctica. Well, we have another big icy thing we want to look at called Europa. Can you help us out? And so they were asked in like the late 80s. It was 88. That's what I have written down in my notes from an interview I did last year with their team. And now they're still involved, which is pretty cool. And they're all very excited to see this journey to this mystical moon. We first started noticing an ocean in there in the 90s in the Galileo mission. they were like, I think there is an ocean down there, and so they were like, we really need to get involved. So I mean, there was some clues before that, but that was when they really had that solid confirmation. Like, I think there's an ocean down there, so it'll be pretty cool. Here's like, look at that cut. So as you can see, like ice really deep, water vapor pouring out, nutrients mixing with the stuff on the surface to the subsurface, which allows this kind of churning to occur. So hopefully, maybe life will form down there. Little green men, I doubt it, but maybe some single cell organisms, or who knows? There could be some like larger
or sea life that we don't even know about.
Larger sea life. There's no telling. The possibilities are nearly endless here on what could be down there. Pretty cool. There's more water on Europa, they expect or they believe, than there is water in all the oceans on the Earth.
Wow.
So a lot of water there, a lot of possibilities.
A lot of possibilities. So I know that this is going to take a while to be completed. Right. What do you think is going to happen once it is completed and let's say it's successful? How do you think we'll develop even further?
So this, you'll have this mission go on. You'll have multiple flybys that occur. They have a set number of flybys. Do you remember what the number is? I wrote it down somewhere on our web store here. But they have several flybys. I believe it's a couple dozen, something like that. I think third paragraph. I can't read it.
49 times?
49, yeah, it's a few dozen. So 49 flybys of the planet or of the moon as they go out. The thing is, they kind of set these goals for these, like the number. We're going to do this. But then they always try to push it a little further because they might be able to make the life last a little longer, get another scan. Yeah. So we're aiming for 49. Maybe we'll get 50. Maybe we'll get 51. It's this. They'll keep trying for it. What's interesting I found was Jupiter is about 400 million miles from Earth, a little more than that. 400 million miles, right? But the spacecraft has to travel 1 billion miles, I think it's almost 2 billion.
To go around.
Just to reach it. Because everything's spinning, everything's moving apart. So as orbits are happening, it has to kind of take an arc to reach there. So it goes basically like double, almost triple the distance just to reach the moon to get to that flyby spot, which is why part of the reason it takes so long to reach this area.
And it's
very,
very
reach
far. There in about 2030, right?
2030. So it's late spring, early summer. NASA headed it as April. I saw some reports as July. So I'm going to say late spring, early summer, and just kind of keep, encompass all that 3-month period, 4-month period there that they anticipate. So they probably have a more precise exact measurement, but I saw multiple measurements for some reason. I think it had probably to do with like when it launched. It originally was supposed to launch this fall, but they were able to move it up to Monday, which is pretty cool.
Well, this is amazing for UT to even be a part of, and I know that you wrote up this article, awesome article for anyone who wants to go ahead and read more of those minor details like the 49 times around.
Right.
All that. What's some other stuff that you have in here that we maybe didn't talk about? I
think we hit everything. It's a really cool mission. It's a great start. This is the largest spacecraft we've ever sent to another planet, which is pretty amazing. That length, by the way, it's not like a big bulky spacecraft. It's like a pod with solar panels. So the solar panel is what makes it really long. But it's really big, really big. I feel like I was talking to some guy who told me it's like a football field across.
Football field.
I feel like it's about a football field across with the. I'll have to double check that answer. But look at it on the screen; it's the size of Jupiter. No, I'm kidding, but it is pretty big. It has these long antennas sticking off of it also, which make it really large.
That wingspan.
The big old wingspan right there. It's a really cool mission. It's to see these decades. So 88, that's like 36 years. 36 years for them to get from the initial, hey, we want you to work on this to now. UT's team should be really proud. It's for the Institute for Geophysics. And they should be, UTIG, they should be really proud of the work they've done to finally get this thing off the planet and now into space. And it has to zoom all the way out there. And just think, can you imagine spending 30 years on a single project? I get annoyed when I spend like more than a week on a project.
Yeah, I would get bored.
Yeah, the dedication it takes to do something like this is outstanding. And just to see it zoom out there and know that your work can carry on for decades in the future, the study of this moon. It's one of the two big planets we're looking at. The other one, of course, is our trip to Mars, which I think, if things are still on track, should be the next decade theoretically, the next decade. We got the moon here in a couple years and then off to Mars. So maybe we'll get to Mars before we get to Europa, but I doubt it. But fingers crossed. Who knows? I'm highly anticipated for that too. It's going to be really cool.
And hopefully we'll be alive to see all of this happen.
Well, hopefully. It's just a couple of years from now. Hopefully we'll be alive. That's dark. Usually I'm the one with the dark sense of humor here. Okay.
Well, you never know if these missions are going to go all the way through or not.
Yeah, fingers crossed. I have a feeling this will be pretty good. They spend so much money, so much time that you hope these things work out well. Occasionally they don't. And we saw with Boeing earlier this year that they had their Starcraft that just had lots of issues and wasn't as successful right off the bat as they hoped. But hopefully I think this one will be pretty good. This has had a lot of eyes on it for 36 years, so we'll see what happens next.
Yeah, well, it's also awesome to be part of history. UT Austin is making their footsteps in space, just like
doing it again. UT Austin, always breaking records, becoming part of history. What can you do?
Yes. Well, thank you for joining me, Eric. Is there anything else you want to touch on before we wrap up?
That's all there is. Don't forget, there's a comet out in space right now. You can get a good look at it. We had a lot of photos sent in, reported at kxan.com of that comet. You can see it in our night sky. Really cool. That's the big one right now, I think. Yeah, that's the big one. You go outside, take a look, see if you can spot that thing.
The comet.
They only come around once in a while.
Pictures.
Yeah, really, really cool.
All of those on our website if you're interested. Thank you, Eric.
Thank you so much.
And that's all we have today on our Space segment. Remember, we have more segments coming up through the rest of the day and into the rest of the week. If you want to catch up more from Eric's story, it's on our website, kxan.com. Thanks so much for joining us.